All right. Hello, everyone. Thanks for checking out our workshop today. We're going to be going over character state machines using Unity. I'm going to be talking a bit about how we did it for my game Dual Major, as well as Shotgun Gladiators. It's going to be a brief overview about what a state machine is, how you can apply it to characters, and then we're going to hop into code and code up some states. If you check out the links up there, you can either grab the repo, or you can go to our drive link to get the Unity package for the code we already have started. Mostly boilerplate stuff. We're going to be implementing the states ourselves, but we set up a little bit of an inheritance hierarchy to begin. Okay, so you guys already have it all downloaded, right? Does anybody need me over there to help them import the package? No? Okay, cool. So while you guys are doing that, we'll do a little bit of an overview. So some concepts we're going to be talking about here that are tangentially related to state machines, but you should know it for the code side of things. We'll be in class inheritance. So we're going to use some show of hands here. The four of you guys, everybody here have some class inheritance experience? Yes? Okay. Who here knows what abstract classes or functions are? Okay. All right, so pretty standard class inheritance. You know, you've got a class, and then you have a class that inherits from that class, so it gets access to all of its parents, member functions and member variables. And if you've taken data structures, you've probably dealt with this before, or even CS1, they talk about it a little bit. Specifically, if you're talking about abstract classes or virtual functions, there's just a couple little caveats. A virtual function is just a function that a parent class defines, and so it could have like function A, and that returns like a Boolean or whatever. And then the child class can just say, oh, I'm going to override A and have my own version of this function. So pretty simple. Shh, spoilers. So pretty simple to have a class, and we'll show you in code what this looks like if you haven't seen virtual functions before. But again, pretty much if you have a class that inherits from another class, then the lower class can override functions and make its own version of functions that the parent has defined. When you get into abstracts, an abstract class is a class that you are not allowed to instantiate. It exists purely so that you can have other classes derived from it. So it's really simple. In fact, the abstract keyword in C# is pretty much just good practice. You don't need to make a class abstract. But if you know ahead of time, hey, I'm not going to actually instantiate this class, I just want to instantiate subclasses of it, then that's what abstract is used for. So if you've got like a class dog or whatever, and you don't have any objects that are explicitly dogs, they're all like, oh, well, this is German Shepherd, or this is Labrador, and you don't want to be able to instantiate just vanilla dog, you make dog an abstract class, and then you have to only instantiate Labrador, Golden Retriever, anything like that. Similarly, abstract functions, again, you use the abstract keyword on an abstract class, and that's just saying, okay, this function, the abstract class dog is not allowed to write this function. Labrador has to write it, or Golden Retriever has to write it. So I know that it exists, but I'm not allowed to write it. One of my children classes has to write it. So that's basically all that is, and that's what we're going to be using for state machines today, because all of our states are going to be derived from the same parent class. So everybody feel mostly comfortable with that? It's pretty simple, just those couple things. Okay, cool. Okay, so actually getting into state machines, and you can see my nice little diagram here in the PowerPoint, which I also already have drawn up there. So if in the future somebody's watching this video on YouTube and I become famous, you'll know what I'm talking about instead of referencing this whiteboard here. Okay, so who here has actually used state machines before or knows a bit about them? Ryan, my man. Okay, we're seeing some flip-flops. Okay, so state machines are a pretty broad concept. The idea is you have several behaviors or states, and in your program, typically only one of these states is going to be active at a time, running its kind of behavior, doing what it says the program should be doing, and then you can define transitions and say, oh, okay, if this part of my program, this state, hits some certain like divergence point, like something's happened, we transition into a different state, which has its own set of behaviors and properties, and now the program is in this state. And so you can see on my little drawing up there, if you're like a character and you're in the idle state, maybe your behavior is saying, oh, I'm not moving, I'm playing, my idle animation where you're kind of just dancing around or whatever, and maybe your impetus is somebody presses the jump button and it says, okay, my state has changed, I'm going to transition to the jump state. The jump is going to have its own sort of behaviors that says, oh, catapult me upwards, do my jump animation, things like that. So state machines are super applicable to pretty much everything. They're super useful. Today we'll be talking about them for characters. Any questions about what a state machine would be, just in the broad concept? Okay, cool. So when and where can I use these? Like I sort of already touched upon, characters are a really great place to use them. That's what we're talking about today. But you could use them for pretty much anything. I know people have used them for setting up levels. So like, oh, if this level gets beaten in under 10 seconds, transfer to level 2. But if it's under 5 seconds, transfer to level 3 or whatever, you know. So you could have logic between moving between scenes and levels and stuff. Animations, another huge place you use state machines. That's really big. Obviously, that's what Mechanim is in Unity. They have an entire state machine thing built just for animations. That won't be what we're talking about today, unfortunately, if that's what you're looking for. We're going to be coding our own state machines. So there's not going to be any nice visuals like this little lovely whiteboard drawing. It's going to be just code. Okay, so this is also drawn on the board here. We're going to go back to inheritance and stuff like I talked about earlier. Yes, there is a reason for having these in the PowerPoint, by the way. One, so you could check online, but two, so I can make edits on the whiteboard for later on. We're going to go a little free form when we get into code. Maybe there's only 4 of you guys, so we can just talk about like, oh, well, maybe we're going to implement a run state or whatever you guys want to implement. So we'll make adjustments on the board as necessary, and maybe we'll have Ryan do some lovely editing, and if we make adjustments to the whiteboard, he'll go add it into the video later. Okay, so getting into some class inheritance. States in this implementation we'll be covering today are going to be a class in C#, and it's called character state. This is just for characters. We're not going to go super generic and have states that could be anything. We're doing just characters today. So character state is the base class. It's going to have a bunch of abstract functions and stuff that all these other states can inherit from, because character state in of itself is an abstract class. You can't just have an instantiation of it. You need to have like a falling state, for example, or a walking state or something like that. So that's going to have most of our functionality in a character state. We then have our next level down, our next branches of movement state, attack state, or, well, anything else. I wrote underscore insert state here. We could do anything, really. But having these delineations of this is a movement state that handles doing movement things, this is a state that handles attacking things, it's really good because part of the benefits you get from inheritance and polymorphism is, hey, I know that, you know, all these states, walking, idle, falling, all those things, are going to share a lot in common. So if I branch them underneath movement state, we could put a lot of their functionality in that code in movement state, and then they all get it for free. This making sense? Anybody's got questions? You can stop me if you do. It's way more interesting when I'm not just like talking at a wall. Okay, cool. So with that, well, actually, before we hop into code, I just want to show you this. This is the dual major state machine inheritance. It's really big. The game was in development for a while, so you'll notice I modeled what our workshop today is after this, but we've got the same behaviors up there at the top. You know, we've got movement type behaviors, attacking type behaviors, but it breaks down a lot. There's a lot of movement behaviors like idle, walking, landing, stopping, sliding. They're different. And then you could break it down further to things related to dashing, things related to air, like going up, falling, recovery, jumping in the air. And having these really specific states is actually super useful because you'll see, like I mentioned earlier, these higher up abstract branches like attack behavior, movement behavior, hold a lot of code. But then you get to the lower level stuff like forward air behavior, like that attack, like the forward air, if you played Dual Major or Smash Brothers. That code will be pretty small. Most of the stuff will be handled by its parents. It's just going to say specifically like this is exactly my timings, like when to spawn this hitbox, when to get in and out of this behavior. They're named behaviors here. Substitute the word behavior with state. Same thing. In this context, anyway. Okay, so with that, let's hop into the code. Okay, everybody's got their scene set up, right? Hopefully you've seen our lovely character prefab. If you haven't, it's pretty great. Let's get a nice look at that. Oh yeah, that's lovely. Great. Okay. So I'm going to go over some of the code that I've already written, some of the boilerplate stuff, and then what we'll do is we'll start to implement our own behaviors. You'll see there's a whole bunch of null references, totally fine. That's because I haven't implemented the behaviors, I've just set up the classes to do so. So let's jump into character state. And again, if I say behavior, that's the dual major developer and me talking. State is the more accurate term. We just happen to call them behaviors and dual major because like, hey, it's a mono behavior. So this is going to be, you know, character behavior, whatever. Anyway, open up character state in your IDE of choice, and we're going to look at that. Yeah, this might take a few seconds. Oh, okay, I'm not going to do this to my eyes or the eyes of anybody else looking. There we go. Lovely. What's up, Brian? I'm on it. Okay. So if everyone's got character state open, I'm going to go over some of the stuff in this file. There's very little implemented here. These are just the function definitions, or declarations. Okay, so let's go over one by one. We've got a rigid body reference. That's pretty self-explanatory. Can use. This Boolean is super helpful for defining if a state can be used at this time or not. We'll get into how that is used a little bit more often later. FPS 60 seconds might sound a little weird, but this is sort of the fighting game developer in me where it's much easier to define things, I think, in terms of how many frames something's going to last. So it's like, oh, at 60 FPS, this is going to be a 5-frame attack or a 10-frame attack or whatever. So this is a little helper variable for me. So I could just say, oh, 5 times FPS 60 seconds is the literal amount of time that I want to pass. So that's all that's used for. Before I go further, you'll notice that this is a mono behavior, the character state. And if you've noticed about my description of state machines, you'll notice there's like a lot of states. So where are all these mono behaviors going to be? Well, they're not on our character prefab yet because we haven't implemented them yet. But the idea is every character is going to have a character manager script, which I'll go into briefly, but that's basically just the script that knows about everything that's going on for the character, all of its states, everything, any variables like its run or walk speed or things like that. And all of these states are going to be mono behaviors that get attached at runtime. So like if you look at dual major when it's running, the character is going to have like, no exaggeration, 30 or 40 components on it because all the states get added as their own component and then disabled. And then only the active state is an enabled component. And you switch between which one's enabled and the rest being disabled, which is a pretty good system. It works pretty well in Unity. There's a lot of ways to do it, but this is a good way to get things up and prototyping quickly. And it's also good for debugging because these different states will be active or inactive in the inspector. Like you'll be able to see like a check mark next to the ones that are active and the rest that aren't will have a deactivated thing. Everybody know what I'm talking about with enabled and disabled components? Yes? Yeah? Cool. All right. So now that we got that under control, like I said, basic setup is you add a character manager, and then at runtime, that manager adds all of the components that are the states. And then those states kind of handle some of their own things. So let's jump back into code and talk a bit about what a character state is and all the functions that it has available to it. Okay, so back to looking at these variables here. Charman, as I've named it, is just our reference to the character manager. That's going to be super useful. If this was C++, character manager would be a friend class of character state because they're completely coupled. They're designed to work together. C# doesn't give us that functionality, but that's okay. We'll just get a private reference to it. And we just set that in awake over here. Same thing with the rigid body. All right, so what's really important about states are these abstract functions down here that I haven't really implemented yet. So there's sort of the main 5, but of those main 5, there's 3 that are even more important. First, we'll go over enable and disable because you're already familiar with those. So these are just the typical textbook Unity on enable and on disable. Those get called by Unity on its own when this component is enabled or disabled. So those are basically, they exist because of Unity, but we're going to sort of hijack them for ourselves and call them abstract functions. That way, this is actually entirely because I was stupid once. And by calling these abstract functions, later classes that inherit from this that want to use them have to implement them themselves. You can't, for example, accidentally have 2 awakes. This was a bug that took me a while to figure out in dual major a long time ago, where the character state at the highest level had an awake function, and then some way lower down, like attack state, wrote its own awake function, and that sort of accidentally override the original awake, and then that awake didn't set up all these variables, and it broke, and I had no idea why. So by making this an abstract function, that can't ever happen again. You have to have an awake function that is inherited instead of making your own. So that's why that's abstract. Same thing for onDisable. These are really good for if you want to set up some variables like before your state starts, sort of like in the start function. And onDisable is really good for cleaning up afterwards if necessary. So you're already familiar with those. Just know they get called. Every time you transition in and out of a state, you'll get those called because we're enabling and disabling our game objects, or our components, sorry. Okay, so here are the more important ones down here that we've written ourselves. First one is update state. So again, very similar to Unity's update, but we're writing our own update function so we have more control. Again, something learned from dual major, it's better to do this than using their update. And I'll actually hop into Unity here and also open up the character manager because this is related. So you see these 3 functions down here that get called in the character manager's update. At one point or another, we still have to use Unity's update function somewhere because that's how our code gets told to run every frame. But what's powerful about this system is the character manager has its update function, but it calls all the functions of its current state. So the current state you'll see up here is just a reference to the current state that you have right now, the only state on the character that is active. And so it has a reference to a character state called current state, and every frame it says my current state dot update state. Everybody following? Good? Cool. So instead of using Unity's update, we use our own update. And that's pretty powerful, and that's good. And the reason we actually do that, one of the main reasons, here's a little example. You don't need to follow along with this. But if I were to write something like if paused, I could just put that right here in this file. Oh no. I could just put something like that in this file here. And now, you know, characters can pause and unpause totally freely if I implement, you know, the ability to pause my game. I don't have to go put code into every single state. Now it's already handled for me. So that's one of the reasons that we do this. There's others, but that's just a nice little thing. We're not actually implementing pausing today, sorry. So we'll get rid of that. But that's one of the reasons. And if you're ever thinking while I'm talking, please interrupt me and say like, oh, why are we doing it like this? Or why are we doing something like that? Because I'm sure I'll forget to cover it. Anyway, so we've got our own update state here. Other important functions that you've noticed there are process input and movement motor. So these are the 3 important abstract functions. These are very similar to update state, but they're explicitly separated out because you kind of want to have these different aspects of a state choose whether or not they get inherited. So for example, process input is going to function just like update, except we're going to be using this for input logic, things that we want to be based on input. Same thing for movement motor. It's going to be called just like update, but it's going to be for stuff that we want to be like moving stuff. And then you can see here, we also always know the order. Update happens first, then process input, then movement motor. So by doing this and having them separated, we know the order that things happen, and we can also specify things like if you're doing really cool polymorphic stuff, like, oh, maybe my walk state, maybe that's going to be using, you know, my parents' update function, but my own personal process input function, and different things like that. Okay, and finally we've got get, can, use here. This is a little bit of a relic of C++ style thing where this is basically just an accessor for our can, use variable that I mentioned earlier. So like, let's say you have like a dodge behavior and you can only use that once a second or once every 10 seconds. If you use that dodge behavior, you want to set it can use to false so that in that next 10 seconds you can't use it again. And that's the point of get, can, use as a function. By default, it's just going to return this private variable can, use. But you know, for a certain behavior, you can override it and say return true only if 10 seconds has passed or something like that. And so that's one of the powerful things about having a function for this as opposed to just a variable. Okay, any questions? We're going to actually start coding now. Sorry, that's probably taken like, all right, good, solid 20 minutes or so of our intro. We're going to start coding now, hopefully be a little bit more enjoyable to watch. All right, so, well, I guess that's a little bit of a lie. 2 more minutes, we'll start coding. So you'll see I didn't implement, but I did create classes for a whole bunch of different states already. So we were just looking at character state. There's also, as I said, the movement state, and somewhere in here, the attacking state. Both of those, I don't know how well you guys can see because I know the font is small, but again, both of those are abstract classes. We already saw in our hierarchy over here on the whiteboard, which is conveniently not in the PowerPoint slide, so I could have Unity open and you guys can see that. Movement state and attack state, those are also both abstracts. Again, you know, delineating stuff so that we can have all of our information separated and have, you know, commonality between states be higher up in the tree. So I've got those set up, and then we have falling state, idle state, jump state, and walking state. And if you look in any of those, they're all basically empty. Here's just, these are just those definitions from character state. And all they're doing is calling their parents' functions. So again, if you're familiar with inheritance in C#, in any inherited function, you could say base.onDisable or base.onEnable or base.movementMotor. All that's doing is saying, call my parents' version of this function instead of mine. Well, not necessarily instead of mine, but just as its own function. I could then do like my own code here. Oh, my own code here. So that it could call its parents' function first and then do its own stuff. So this is where a lot of the power is going to come in from doing states like this, which we'll see in a moment. What's up? You have to write this. If you don't want it to be called, you don't write it. And again, it might be a little complicated at first, but that's how this is powerful because, for example, in dual major, a lot of the times we didn't want to ever call the parents update function because usually you want that to be exclusive to you. You want your own unique update if you say like, oh, I'm GSAS's version of walk. And I don't want to call the generic version of walk, I want my own. So you'll notice I actually didn't have that written here for the update state. I didn't put that because that's usually true about updating state. However, movement motor is something that oftentimes you do want your parents' version of instead of writing your own. Same thing with process input, which if I opened up, if I opened up movement state, again, also empty. However, here I've already declared process input. You'll see soon when we get into the coding that oftentimes process input is something that you want one of your parents to define for you because, for example, most movement states do the same thing with the same input. Only special cases will say, oh, I have my own special way to handle this input. Most movements want all their input to be parsed the same way, so they won't end up writing their own version of the function. They'll just call their parents. All right. So I lied last time about starting the code, but now we're going to start the code. So first, let's do an idle state. So before anything, idle state, we don't need to have, it's not an abstract class. We don't need to overwrite it to do anything. This is actually just like one of our leaf nodes in the inheritance tree. So first things first, I'm going to bring my character manager over here and my character state over here because I think that's easier to organize. And if you need me to hold open a script for longer, just let me know. Because one of the kind of cons of this system is that you do have a lot of scripts and you do have to move in between a lot of them, which can be cumbersome. I think it's usually worth the power that you get for having everything separated, but just one of the cons. So when we're going to do in our awake here, or actually up here actually, I have this section, references to the character state components go here. So part of the reason for having character manager is that it has a reference to all of the states that this character owns. So we're going to go public, actually we'll do idle state first, idle state, idle. Okay, actually I'm going to make this a property. Is anyone in here not familiar with Unity properties? Don't have to be ashamed, I'll go over that right now. Yes? Okay. they're really cool. All right, so we'll go into this briefly. Character properties properties in C# are basically a way of setting getters and setters for a function. So, and it's going to look something like this. You can write a get function here. So if I wanted to be like, oh, do stuff. And that would be every time you want to get this variable, it'll do stuff, and then, return this variable. So basically, you can write code to get called whenever somebody asks to get this variable, or anytime someone tries to set this variable. So it's really cool. It's the same thing as if in C++ you wrote getter and setter functions and used those exclusively. However, this has it built into the variable itself, so that's really cool. However, in Unity, I also just use it to sort of cheat. And if you don't want a variable to show up in the inspector, but you still want it to be public, you can just define getter and setters, and that makes it a property. And properties, by default, don't get serialized and put into the editor. So that's a little reason why I'm doing that now. The shorthand as well is you can just write get, set, and not define the functions, and that by default just treats them totally normally. Oh, come on, don't do this to me. I don't want it. Okay. So yeah, the quick shorthand, you could do get, set. This is also super powerful because you can do like get, notice this is a public variable. I could do get protected set. And now this is a read-only variable to everyone except classes that inherit from this. And that's super nice. So that's just one of the reasons why it's powerful to do this. Okay? So that's a property, and it's the same thing as a normal variable outside of that. Besides the fact that I added those curlies with that, you just treat this like a normal variable from now on. So that's our reference to our idle state. We're also going to get a reference to our walk state. And we're going to do the same thing, get protected set, so that it becomes essentially a read-only variable to everybody except character manager or one of its child classes. So we got our idle state and our walk state. Let's also do this for falling. Whoa. And what was the last one I added here? Jump. All right, and I'll give everybody a second to type that up. And so you have to do this for every state. So I mean, again, this is where it comes in where sometimes this system can be a little bit cumbersome, but it's worth it in the end. It might be hard to see that by the end of this workshop, hopefully not, because this is the sort of thing that really pays off when you have really big systems in like a long-term project. So it might be hard to see it pay off initially, but you'll have to trust me on it. Has everybody got this written down? Yes? All right, cool. So that's the references to all of our states. Great. Now what we're just going to do in awake is we're going to set these references. So we're going to do idle equals add game object dot add component, please. Oh, that's upper G. Add component, and we're going to add component of type idle state. And now, like I said, at runtime, the character manager adds all of the states that it wants this character to have. So for every state, we also need to do this. Everybody comfortable with what we're doing right now? If you're not familiar with anything that I'm typing, please stop me. There's only 4 of you, so this is hardly a stand-up lecture. I might be like 15 feet away from you guys, but pretend I'm right next to you. To add a bunch at once? Yeah, that'd be nice, wouldn't it? Maybe they do. There's always more functionality you're not aware of, but I don't believe they do. It's okay because you only need to do this once, sort of. You add all the default behavior something's going to want. One of the reasons we do it like this as well, this whole system is really powerful for when you want to have a lot of different characters of the same type. or similar type characters, like in Dual Major, which is, you know, fighting game like Smash Brothers. All of the characters, you'll notice, are probably going to want to have like basically the same idle, walk, falling, jump. And they don't have to write their own versions of these. They could just say, oh, I'm going to use, you know, idle state, walking state, falling state, whatever. But for things like attacks, like every character has its own, you know, special attack when you press the B button. They all override the B button special attack behavior or special attack state and say, this is explicitly mine. And then they get their own character manager that inherits from this. And then in their awake, they just say, oh, okay, don't give it a generic, you know, abstract B special attack. Use my B special attack. And that's where this becomes powerful, because everything else about that character could be identical to the other characters except that one move. So that just means on that one character specifically, you attach their version of the attack, but everything else attaches the same type of component. You could also, I mean, for that reason, you could have these components already added in Unity if you wanted, you know, before runtime, like on the prefab. However, that would mean that for each different version of a different character, you just have to go and swap them out yourself. Not a huge deal. However, you'll soon notice, like in Dual Major, where there's 40-odd behaviors or 40 states, that would be really messy to have in the hierarchy all the time, or have in the inspector all the time. So we just add them at runtime instead. Okay. So everybody's got those references. We've added all of our components. That's great. They're going to be there now. If we hit play, we'll probably still see null references, but you'll see, at least you should see that they're all there. Oh, hang on. Hang on. Let's see. Why is that happening? I might have to bring up my reference code. Hang on one sec. Oh. Okay, a couple other things that we forgot to do. So what we want to set at the beginning is our current state. We just want to set that equal to idle, because that's where you're going to start in, and you don't want your current state variable to null reference. And okay, great, there we go. So now, didn't null reference, and you see it added in our inspector over here, our idle state, walking state, falling state, jump state. They're all components. They also, you can see that they've all, FPS 60, I should make that not appear in the inspector. But you see they're all there and they're all disabled, because the way that the state machine works is, by default, all of these states are disabled, and then when you want it to work, you just enable it, right? Okay. Cool. That also reminds me that we want to say current state dot enabled in awake. This is only something you need to do for the first time. However, just have to sort of hard code it here so that the one state that you want to start in starts enabled, because by default it's all disabled. So now, if I hit play, there we go. Idle state's got that little check mark. So usually what we do is sort of close all those, because you usually don't care about the internal variables per state. And now you can see, oh, the one that's active's got a little check mark. Yay, okay. Everybody at this point? Yeah, cool. Are you following along, Ryan? Oh, see, Ryan, you're the best. Okay. All right. So let's work on transitioning to our walking state. That's going to be next. Because obviously idle is the first thing that you do. The second thing is going to be walking. So, and actually let's, yeah, actually we're just going to do this for here. So if we go into our idle state.cs, by the way, is this big enough? Can you guys read that okay? Yes? No, you're shaking your head sideways a little bit? There you go. Just for you, Noah. Okay, so if we go into our idle state, we're gonna, right now it's inheriting its process input from up here, which is great. We do want that. However, we're also gonna give it its own process input. So we want a public override void process input. And because our IDE is so intelligent, it knew that's what I wanted to type. So by auto-completing it, it also gives us the base.process input there, which is super nice. But we're also going to do a thing here that says if input dot get access horizontal What's up? Is it capital H? I was going to go check afterwards anyway. Lovely. So if we get that float, and let's just say not 0, actually. We'll just say, no, that's actually a bad habit because sometimes floating point precision. So we're going to do mathf dot absolute value of it because we don't care if it's negative or not. We just want to make sure that it's something. So if it's absolute value, it's greater than 0. Lovely, okay. All right, so now we get to use my favorite function when it comes to writing character state machines, our change state function, which is awesome. So for now, just copy down what I'm writing and then I'll explain it. So change state, we get that, that it's inherited from the character state. And what we're gonna do here is char man, which if you remember is our reference to the character manager, which it should have access to. Hang on. Oh, that's not private, that's protected. Whoops. Make sure you go change that, everybody. That variable wants to be protected so we can access it, no problem, from the children. So make that protected. And we're actually gonna use our nice little trick, once again, of get this time private set. So only this class can set that variable and we can't see it in the inspector. And other people can read it, but they can't set it. So make sure you do that. And then down here we're going to do change state. So charman, our reference to our character manager, dot walking, or dot walk. And what that'll do is change us from our current state into the walking state. And it doesn't care what our current state is. I mean, our current state happens to be idle because this function process input is in idle. But you could use this function in any state, and you just say change my state to whatever my character manager says walking is. And again, this ties back into the power of the system. I just know that this is a reference to a walking behavior, but I don't know anything else about it. So if this is a character that says, oh, I have my own unique version of the walking class that I inherited, and that means that when I walk, every time I take a footstep, it hits the ground, there's like a big explosion or whatever that is unique to that character. Idle state doesn't need to know that. It just needs to know that the character manager has a reference to some walking behavior or some walking state. It doesn't care. It knows it's a walking state, and that's all that matters. If we look in the change state function, so you see this is actually defined in our character state.cs, and it's pretty simple. You pass it a character state, and it says new state.getCanUse. Remember I mentioned that earlier. It just calls that function and sees if this state is able to be changed into right now, which by default it is going to be able to. But this is a really good check to have. It lets you make your code a lot easier so that the state itself handles whether or not it can be changed into, not anywhere else. So then it does is it saves your current state right now as your previous state. We won't be using this variable at all in this example, but it's a good practice because maybe you'll have a state that cared what state you were in last. Like maybe if you're in the dodge state, but you were just in the falling state, that means that your dodge goes farther or something, you know? So it's good to keep track of that, what your previous thing was. So it sets your previous state equal to your current one. It will enable this new state. It'll then say time since started is 0, which just means that this new state, there's been 0 time since you've just recently transitioned into it. and then it'll set the current state equal to this new state that you've got, and it'll enable it, right? So pretty simple. It also will return false if for some reason you weren't able to change into the state. That usually won't happen, but because you'll be coding the rest of your states with the knowledge of when they can and cannot change into each other. But it's good to have there. Okay, so that's all that function does. Sweet. And so we've got this here. I'm just going to go check and make sure that the horizontal access is set up in this Unity project, which I urge you guys to do too. It should be already, but horizontal with a capital H. Cool. All right. So now, if I'm not mistaken, if we play, oh, hang on. Let me just.
One eternity later.
Okay, so nonsense aside, we can now change to our walk state, no problem. Now all we're going to do is hop into the process input for our walk state and then say if you're not holding anything on the axis, then go back to idle so that we can go back to our default state. Like I mentioned earlier, and you can see on the board in our little diagram there, our idle state gets that little dotted line around it saying it's the default state, and that only is really there for our personal use. There's nothing special about that state. It just happens to be, well, when you're not doing anything, we want you to idle. So there's, you know, all paths should sort of lead home there, saying if you're not doing anything, you're going to be going back to idle, right? Hmm? Oh, okay. One of our audience members is saying if there seems like a weird gap in the video here, we did have a problem in our editor where if it seems like your states aren't changing at runtime, like that little check mark going from there to there, try twirling open these things, because apparently, depending on your version of Unity, it might not update the visual representation of what components are active, even if the logic is sound for transitioning. Okay. So, back in here, we're going to, in our walking state, just add a little bit of code. So if you're not pressing on the axis anymore, we just want you to go back to idle, because we don't want you sitting in the walking state. That's not our default state. So we're going to do our protected override, or our public override rather. Public override, and that's going to be our process input. And we're going to keep the base call in there. But we're just going to add if, excuse me, our get input, or rather input dot get access on horizontal, and if that does equal 0, then we're going to change state back into our walk idle. So charman dot idle. And now, if Unity is behaving properly this time, we go in and you can see we hold walking and we let go and it goes back to idle. So we now have states that are moving around. Sweet. They're not doing anything. I mean, we've got a really sexy character over here that's not doing anything, but hey, the states are changing and that's what's important, right? Everybody caught up? Yes? Seeing a nod here or there. Yeah, we good? Okay. Nice and simple. We can actually put stuff in these states now that we know that they're changing. So let's go to the process input of, actually let's go into the update state of walking here. And so in walking, let's just do, oh, I don't know, we're going to add a force, I guess. So rigid body, I did it again. I'm sorry guys, I pushed before updating from some of the stuff in my reference. We're just going to need to go update in character state. We want our rigid body to be protected so all the inherited classes can see it too. Protected. And actually we're going to do that for can use. Got a little overzealous with our private variables. I'm sorry. So just add those to protected so that we can access it later in walking state. And we're going to say rigid body dot add force. And let's say we'll make a vector 3. And this is going to be in the x direction because we're just doing like a 2D sort of thing, or 2.5D, I guess, because we're using a sphere. So we're going to get axis. Get axis horizontal, and we're going to multiply this by charman.walkSpeed, because we already added that as a variable. And that's one of the other, important parts about having the character manager. It holds on to all these variables about the character, and you could edit them in the inspector, which is nice. So anything like health, walking speed, running speed, a whole bunch of other various things that a character would need to know about itself, you can just access via charman. This sort of stuff isn't held in the state. It's actually better this way, so it's easier to just edit these variables later. So we're going to say that's x times the walk speed, and we're just going to keep it whatever it was before. We'll just say 0, I guess. And then we've got our vec, and we can say vec here. And I realize that this is actually like pretty crappy syntax because we're adding the walk speed as a force, but this is just the quick example to get it working. Obviously, you play with how you want to do it. In actual implementation, in dual major, we just set the velocities, which also has some cons associated with it, and I wouldn't necessarily recommend it. But there's a whole bunch of different ways to move your character. This is just the quick, I'm showing you guys how to use states. So, yeah. If you really want to get fancy, use a nice animation curve and, make it nice. But we're not doing that right now. We're doing the lame approach. Huh? Oh, I forgot to add a rigid body, didn't I? Rigid body, make sure you add that. I should have added that before I pushed the workshop safe version, but I guess I didn't. See, that's the problem when I was making this workshop earlier this morning. And last night, but earlier this morning, and I'm testing stuff on my end. I first had to push the version that you guys would all start with, and so I didn't know everything that made it into the reference version versus the downloadable version. That's okay. Just out of curiosity, who here cloned this repo versus using the install? You cloned it? Anybody else clone the repo, or do you guys all just install the package? All right, good for you, Dylan. I appreciate it. See, that way, if you really want to go deep and make your own state, and you could push a pull request for it, and I'll accept it, and no one will ever look at it because it's a workshop repo. But that's okay. Repos are way better. Maybe in the future we'll require it. This probably isn't going to work because I probably forgot something, but yeah, you know what? Actually, I'm doing it the bad way, but this is, oh well. We're cheating here, guys. That way we can just keep our y velocity and z velocity the same, and we're just going to set the velocity directly because I'm lazy, and this is how we did it in dual major. Also, because this is a 2D game, we're going to freeze our rotation along the x and z because that's not how this works. And then, still not working. Might need it. Huh? Oh, thank you. I don't know, let's make it 500, yes. Please move at 500 meters per second. There we go, okay. So now we've got our character moving around super dinky, but that's okay. I like him. Is everybody up to this point? You need to bring the code up. It's just those two little lines here where we're setting the rigid body velocity using your input times your walk speed. All right, now I'm going to walk around and see you guys' lovely moving characters. Yeah, I mean, that's really I don't know where people are in their knowledge base and stuff, but I'm basically just trying to show off how I implemented it for dual major. Maybe it would be better for a discussion than a workshop, but whatever. Okay, David, or no, actually, Ryan, you can edit back from this point. Okay. So we've got our shitty little walking. I've set up jumping and falling, and we can try and implement those real quick, and then we'll probably be done. I mean, hopefully you guys are starting to see, you know, the structure and setup for this. Obviously, we don't have the time to like really dig in deep and do stuff with all the different functions and stuff, but hopefully if you understand the structure and why everything is there, you could implement this for your own games in the future. Or just use this exact code if you want, you know, that's fine too. So here's something that is cool about this system. We're going to go into movement state. And you know I mentioned earlier about inheriting stuff. One of the powers of this system, and I'm going to bring up again the slides. Oh, perfect, right on the slide that I wanted to. That in dual major, there's so many different states, so many different behaviors, and a lot of them have a lot of things in common. For example, most of these movement behaviors want to allow you to jump if you press the jump button. And it would be silly to code that into the process input function of every single one of these behaviors. If they all want to jump because they're all movement behaviors, why bother having all of that, you know, having all that code? The whole point of having this much inheritance is reducing the amount of copied code, basically, or the occurrences of the same code. So you should really only exist once if you're going to use it more than once. Maybe if it's like using something twice, maybe you'll just sort of hard code it, copy and paste it twice because you're lazy. But if you're going to, you know, do the proper good system, you should really have the same code only appear once. So for something like jumping, we could go into movement states process input and do the check for a jump there. And so we can say, hey, if, you know, input dot get button down rather. I believe by default jump is set up as a button in Unity, right? Yeah. So input dot get button down jump, we can change state to jumping. Charman.jump. And just to make sure that that went okay, we're going to go into Unity and say, okay, good, it transitions into jump just fine. So then what we'll do is go into jump, behavior, jump state. And we're going to say, actually we'll put this in the update, because I did want to show off something else that I normally do. So what we'll do for the update state, what? Oh, thank you. Big enough? Cool. So what we'll do for the update state, this is something that I typically like to do with when I write these sort of state machines. So we're first going to say time since started plus equals time dot delta time. And it might feel a little annoying that we need to put this in here. Huh? Really? Is it? What? Did I just, did I do it again? Please. Yeah, I must have done that. I was way too overzealous with my privates versus protected. Okay. So, it might seem a little tedious that you need to do time since started plus equals time dot delta time in the update state. Part of the reason that I personally choose to do it this way is to avoid having the extra infrastructure of, again, you could say, you know, base dot update state, please. So you could do that. But, like I said, a lot of the times you want the update function to be completely unique. And so if you're just calling the parent just to have it increment the time, that's a little bit annoying. You could have a Boolean for like wants time since started increase or something for each state, and then have that be updated in like a coroutine or something. again, adding a little bit of extra unnecessary infrastructure. So I just think it's fine just to add that here in our update state. And then what we do is we're going to check to see if time since started is greater than or equal to, we'll say 4 times FPS 60 seconds times delta time, please. Times time dot delta time. Okay, so several things there, but hopefully what we're doing should be obvious. What this is saying is if you've been in this state for more than 4 frames at 60 FPS, which is how, if you're a fighting game person like me, you want to measure time because it's easier. So if you've been in this for 4 frames now, that's when we actually want you to add the force impulse for the jump. Because, again, if we're doing fighting game mentality, we don't want the jump to happen immediately upon pressing the button. We want there to be a little build-up. So what we can instead do is see if it's been 4 frames or not. Another thing that would be good to do, which I, again, won't be showing off in this little workshop here, would be in your on-enable, you could be like animation.play some animation. I know this is the older animation component. I'm a little dated because I don't really use Mechanim too much. But if you would use animation.play for whatever animation you wanted to do, like let's say it's the jump animation, and let's say the jump animation is 4 or 5 frames long, what you could then do is just say play the animation in on-enable, which is typical behavior for a state. You start the animation as soon as the state starts, and then you can check to see here, instead of that, you could write if like animation dot is playing, or is playing, or the Mechanim equivalent, you know, and sorry, if animation not playing. So if the animation is finished, now is when I want you to do the jump impulse and then exit out, right? Well, because we're not using animations right now, because our little Ben Chang character is just a sphere, we're going to check if it's been 4 frames or not. And so what we'll do is, once it's 4 frames, we're going to change state, and change to falling, realistically. And then before we do that, we just want to add the impulse. So be rigid body add force. I don't know, what's a good jump force to put, like 20 newtons? That's not going to go very high. 20 newtons at something that's 1 kilogram probably wouldn't move very high, I don't think. We're going to try 500. Maybe that'll be way too much. That's okay. And let's make sure this went through okay. Yay! Sick. And then you're in falling when you do that. What am I doing on time? 318? All right, so we'll just implement real quick something to transfer you out. So what we can do here is, in the interest of time, okay, and then what we can do is, if you're in Falling's update, huh? Yes, thank you. There we go. We'll do if physics.raycast, and we'll say, there's always a million ways to do a raycast. New vector 3, actually no, we're going to start, sorry, transform dot position, and we're going to do vector 3 dot down, and we're going to want to be, I don't know, like 0.75, we'll say, about 0.75 meters long. And then, what argument am I forgetting? None? Wait, why is... Oh. There we go. Okay, so that's going to be our raycast just pointing down. So we're just going to say if you're falling, whenever you detect you're about to hit the ground, we're going to transfer you back into idle. Or if you're making a real game, we would have a landing state, because then you can say, oh, I just landed, but, you know, sort of as an amount of commitment to this jump you just did, you land and maybe you can't actually move for 4 or 5 frames or whatever. Maybe shorter, maybe 2 or 3 frames. You don't want to be that mean. But, you know, adding a landing state would be good. But in the interest of time, we're just going to transition back to idle. And let's see. So now it should, hang on. Oh wait, did I transition into falling? Yeah, it goes into falling state, and then gets here. So we should be okay. Is it? Hang on. Oh, but then immediately goes, you're right, you're right. Oh, that's something we had in dual major too. So, let's go back to what we already did. If you're in falling state, I mean, the quick thing you can do to cheat the system is something that we've already done, and say, hey, you know, if time since started is greater than or equal to, I don't know what, like 5 or 6 frames. We'll say you can't go into landing until you're that far into the state or whatever, times FPS 60 times time, time dot delta time. Then that could save us a little time and say, okay, well, you can't actually transition out of falling right away. And then that can prevent that raycast from giving you issue. There we go. And now actually something that I totally forgot that is usually good practice is after you change state, you probably want to have a return, which I totally forgot that I should mention, because obviously it'll still keep stepping through this function after you change the state. And even though we haven't written anything yet where that would really be a big deal, generally a good idea to return afterwards so that you don't call the rest of the stuff that's in that function, because you probably don't want to if you just changed your state. Anyway, that's pretty much it. Well, all I had planned to cover today. Is there anything else that you guys had as questions, or is anybody still trying to catch up? No? Anything? Okay, well, we're probably going to call it then on the coding end of things, and if you want, whoa, okay, I'll jump into the slides really briefly. So, the shitty little state machine that we just implemented here with just a couple little states that aren't doing very much is a single state machine. That's what we did for dual major. That work, for the most part, is pretty decent. There's, you know, attacking states, there's moving states, there's a whole lot. I already showed you this. But you can only be in one at once, which is good for a fighting game because you don't want to be able to be walking while you're punching someone unless that like unique attack allows it. Usually it's like, oh, I punch this guy, I stop what I'm doing and wind up and do this nice big punch. So everything is pretty exclusive. You only have one behavior, one state going on at once. However, it's worth mentioning a double state machine, which is something we use on Shock and Gladiators, where at all times you had 2 active states, and one of them was an upper body state and one was a lower body state. And so the lower body would handle all your movement-related stuff, and the upper body would handle all shooting and attacking-related stuff, so that you can't be reloading while shielding, for example, and that sort of thing. But you could easily be walking while shielding. And so that might be the sort of thing that you would want to implement, especially in like a 3D game. In a simple little side-scroller like Dual Major, having a single state machine is really what we wanted. It makes the most sense. But if you have like a complex like animated character in a 3D environment moving around with a bunch of stuff to do, you might want to do like a double state machine. It's worth bringing up as well, composite or with components. And this is something that if you know Dom, he advocates for quite a bit. And it's similar to what we've been doing. The only difference being you add a couple extra components to control things. So how you always have, all your states on your character as components, and you always have your character manager. The only difference would be for things like, let's say you wanted to have a state that moves your character around, which obviously you're going to want. You also have a component that would be called like a character movement component. And what would happen is if you're in like walk state, it would say, all right, get a reference to my movement component and tell the movement component that I want to walk at this speed or something like that. And then that component, the movement component, will say, oh, this state wants me to move at this speed? Well, sure, I'll do that. However, it can have some extra checks like, well, am I walking on ice or am I walking on grass? Or maybe I have a power up right now that says I move faster than I normally do. And so the idea is there's sort of an extra layer of abstraction there. And that can certainly be useful depending on the kind of game you're making. But yeah, that's just some different ways you might see character state machines being used. That's it. If you guys wanted to discuss stuff, maybe ways that you've used this or questions that you have about it, I know obviously I can only cover so much in like an hour and a half, and there's a lot of stuff that's been done in Dual Major and Shotgun Gladiators that I didn't have time to bring up, but yeah, we can talk. That's pretty much it.